Welcome back, everybody. It is time for the Student Mentor Showcase, and this week I have with me Mentor James. You can go ahead and say hi.
Hello.
So, James, you have a rather cool project and one that I'm going to go ahead and say I have a personal bias towards. Go ahead and tell us what this project is, and I'm going to push your video feed to the stream. It's a little grainy. We're having some Zoom trouble, but I think everyone can see it just fine. So,
Yeah,
tell
so
us,
this
yeah.
project is using a Raspberry Pi, a few cameras, distance sensors, and a lot of other components to try and help blind people to see a little bit better. Eventually, this will all be compacted down into glasses format, but that's a well ways into the future. So that's a general overview, and I'm going to get into how everything works.
So correct me if I'm
Uh,
wrong. You actually started out using not a Raspberry Pi, but an Arduino, right?
Actually, yes, I have a kidOYO Arduino right here. This is an
Nice.
Arduino Uno. Um, I got this a while back, but I originally used this for all of the distance sensors and an accelerometer, magnetometer, and a gyroscope. And I was originally going to use it to plot out a room, either 2D or 3D. But one of the issues that I ran into, and I even talked to you, Mentor Doug, about this, was if the person were to move in the room, how to calculate where it is. And in the end, we decided that it wasn't possible to calculate with any degree of precision where the person is in a room.
Yeah, and for people just listening to this now, I'm going to go ahead and say this is a very tough project to tackle. On its face, you start learning some of these sensors, like, oh, I can do this. And when you dig into it, and James has dug pretty far, you find that it is not as easy as you think it's going to be. And so you switched from the Arduino to a Raspberry Pi, and just for everyone listening, to clarify and give some background information, an Arduino is referred to as a microcontroller or a microcontroller platform, and a Raspberry Pi is a full-fledged computer. The difference between the two being that an Arduino pretty much just runs the one code file you upload to it, and that's all it does. And it can run that code file real well, but that's all it can do. A Raspberry Pi, on the other hand, being a full computer, has an operating system. You can have multiple things running at one time, and it has a much more powerful processor, and even later models has separate things like a separate GPU, HDMI output, and I'm going to go ahead and guess that's what you're using for this project, right, James? Is this a Raspberry Pi 4 that you have?
I am. This is actually a 4B plus, right, that I'm holding right now. I originally had the Uno, and then I decided to go to a Pico, which is it's a better version of an Uno manufactured by Raspberry Pi, but it is a microcontroller. Then I tried out the Raspberry Pi 4, but this is a bit big to fit in a glasses frame. So Raspberry Pi thankfully sells a smaller version called the Compute Module 4. And that is the little black thing on the screen. And the little black thing is a heat sink to dissipate heat because it does get quite hot. It works pretty well. But underneath it is a very small green board. And that is this entire board compacted down. And it removed all of the ports. And you could buy an external IO board, is what they call it. And that's what I have below. And that has two USBs, Ethernet, two HDMI outputs, two display outputs, two camera outputs, GPIO, PCIe, which I'll talk about later, SD card, etc.
Nice. So did you say you actually have on that green board that you have in front of the camera, you actually have a whole Raspberry Pi 4 incorporated into that PCB?
Yes, it is actually 4 gigabytes of RAM. It doesn't have any onboard storage. I decided to offload it to an SD card in case something got corrupted on there. It has Wi-Fi and Bluetooth built in, and that's the specs for the. But yeah, this entire that little black thing right there, it's blending in with the PCIe right here.
Yeah,
But
would you be able to I
tilt
know
it,
you
yeah,
have a lot of wires here. Yeah, could you bring it closer to the camera maybe or tilt it? Ah, okay.
yeah. So this
Nice.
with the 4 screws in the corner, I can move these wires here, but that and the little cutout is for the wireless. But this right here is the compute module 4. And eventually, since this IO board is completely open source and I can look at the schematic, I can create my own circuit board based off of this.
And where did you get this circuit board?
I went down to my local micro center, which is pretty close, and it's the cheapest way to get it. So I just bought it there.
And which Raspberry Pi? I'm not sure I'm familiar with this. Which Raspberry Pi product is this?
This is the Raspberry Pi Compute Module 4, abbreviated as CM4.
Oh, right. And I may have missed it when I think you may have mentioned that, and I just missed it.
It's okay.
All right. So you have the compute module. It has the Raspberry Pi 4 as well as a bunch of different peripherals that make it easy to interface with different devices. What do you have connected on that breadboard? And just for people who may not be familiar, the breadboard is that kind of long white rectangle that all the wires are going into.
So yeah, I'm using the GPIO pins, which are over here. And on the rails on this breadboard, I have power, 5 volts, and I have an I2C bus because a lot of devices are using the I2C bus. So starting from the bottom, there are 2 buttons. One will be for the assistant and one for the settings. I will demonstrate both, hopefully. Then there's an I2S microphone, not to be confused with I2C. It uses 3 wires instead of 2. That's what I2C uses. There's an audio amp for the bone conduction speaker underneath the electrical tape. The reason why it's underneath this electrical tape is so that you can hear it. I'll also be demonstrating that. And then before I go right here, the 3 sensors at the top here, these are called time-of-flight sensors. They are the VL53L1X. And similar to sonar, which you may have heard of before, instead of bouncing sound off of an object, it bounces a laser off of an object that you can't see the laser. And it can measure up to 12 feet away, which is very impressive. And that is, since these are all the same device, you have to use something called an I2C multiplexer to address each of them. That's right here. And finally, the final thing is an I2S speaker with a headphone jack, which connects to the amp for this. And you can also plug in headphones.
Awesome. Yeah, so I think maybe did you start prototyping with the ultrasonic sensor?
I did. That was the first thing. Yeah.
Yeah, so ultrasonic sensors are pretty cheap, really nice to use. However, there's a bunch of big problems with them. Yes, if you hit the wall at a wide enough angle, it's not going to work. But also, try to look at a couch. Some soft objects can absorb enough of the sound that you don't get good feedback. Time of flight is a much higher quality sensor. You're going to get better data from it. And then what you're doing with the multiplexing the various sensors is pretty impressive. So what stage is this at? You said 3 time-of-flight sensors, right? I'm guessing left, forward, right?
Yes, I also forgot to mention there's a Pi camera right here connected to the I/O board through the tiny camera cable. But there is definitely a lot of stuff left to do. For example, there will be vibration motors. It's very small right here, used to indicate how close an object is, and there will be one on either side. Then there will be, of course, powering it is a whole different issue. I'll be using LiPo batteries around 4,000 milliamp hours, along with this Power Boost 1000C from Adafruit to power that, and also a potentiometer for volume control, amongst other things like inputting Wi-Fi, for example. Remember that they are, in fact, blind, I'm assuming, so you can't ask them to type it in on a screen.
Yes. So at what point is your project at? What kind of data are you pulling in? What kind of output can you give? How's it working?
Oh, okay. So there are different. I've separated them into multiple different parts, and the one that uses the most data would be image recognition. And the image recognition, it uses TensorFlow Lite, which is artificial intelligence made by Google, and it uses object detection. So it detects multiple objects in the frame, which is very difficult to do instead of classifying a single object as something. I think I'll get into that in a little bit. And then it combines that with the distance sensor. So it gets the distance sensor data through the multiplexer through I2C. And here it processes that. And if it's below a certain amount, because an image can see something from tens or hundreds of feet away. So it only matters if it's a certain amount of feet away, which you can customize. So it uses the distance sensors and it uses the camera to detect if an object is in fact in front of the user. Then there's also navigation, where it uses the 3 distance sensors. It gets them in just like before, and whichever one is the shortest distance at a certain distance threshold for the front, you can navigate to certain areas. I even have plans for a GPS, possibly for GPS navigation, but that's pretty much all the inputs. And then outputs is just the speaker, and also the microphone is an input, and the buttons.
Oh, okay. And that explains why you had the camera. I was going to ask, because those time of flight sensors are going to, obviously for someone who's blind, they can't see. So those time of flight sensors are going to give them some data back, some information on what's in front of them. But you can then start to sense what it is like that object in front of what that object in front of them is. Which could be hold a lot of importance. And then also, I just want to point out the bone conducting headphones are speakers are a pretty nice touch. For those unfamiliar, yes, you normally hear with your ears, and sound comes in through your ears, vibrates your eardrums. That causes an electrical signal in the brain that your brain interprets as sound. But also, if you have a vibration connected to that bone behind your ear, and if you want to go ahead and just tap that bone behind your ear, you'll feel it. You can actually send vibrations, and sound is just vibrations in air. So you can send vibrations through that bone, and you will actually hear it, and that will allow you to keep your ears open to the world while simultaneously hearing things without having to play them on loudspeakers that's bothering other people. So that's a very nice, discrete way to get some sound input in without blocking out any external sound. And I'm guessing that was probably your thinking behind it, right?
Yes, that was.
Awesome. So are you about to run some code for us?
I will. I have connected to the Raspberry Pi through SSH, which is the easiest method to connect to it. I guess we can start with the Smart Assistant, which I decided against using something like Alexa or Google for the Smart Assistant, which I have implemented in. So I decided to create my own pseudo assistant. It obviously can improve with time, but let me just make sure I have it. Okay. And I'm using Python to create all of these codes. So one of the features that I added, I guess you can call it a feature. It was also me not wanting to do live recognition. It only recognizes your voice when you press the button. And it's the second button. And that's a bit hard to see. But if I were to press the bottom button here and hold, and I say, "What's the weather for today?" And it recognized it. And if you give it a second, I hope you can hear the phone conduction. Did you hear that?
We couldn't make out what it was that it was saying, but we definitely heard it, and that's awesome. So you asked for the weather, and it gave you the answer back. Do you have a temperature humidity sensor, or are you pulling from an API?
I am pulling from the Wolfram Alpha API, which I found is actually really helpful. And as a backup, I also use Wikipedia for more general stuff that Wolfram can't answer. And if not, it just says I couldn't answer that. But it gets almost every question.
Yeah, that's awesome.
That I can ask it. Yeah. So that is the Smart Assistant. And you can also ask it in the future when I implement it, you can also ask it custom commands, because this is a custom Smart Assistant. So I can ask it to read out the battery level, to disable something. But now I guess we can go to the other button, which is settings. This one is actually really basic and it's kind of glitchy, but you just click the button, and if you click it once, it should rotate through. Occasionally, I am running everything on a Pi 400, so a Pi running a Pi, but the Pi 400 occasionally disconnects Wi-Fi. I'm not sure why, but since SSH runs on Wi-Fi, that's kind of an issue. So you can rotate through everything, and there's a bug right there. But you'll be able to disable things like change the vibration pattern, change the Wi-Fi, change the distance that it reads. So those are all things that will be changed in the settings. That was just a small program, but
Nice. And do you have those distance sensors implemented right now?
yes, I can show you that. I can show you the. So it is currently reading out all three values for the sensors. The first value is the forward sensor, which is kind of glitchy. But if I put my hand in front of the forward sensor right here, it reads a very low value because it is reading in millimeters, by the way, not inches. And it can read up to, again, 12 feet. If I cover the right, the bottom value, which is the right value, goes down. And if I cover up the left sensor, it goes down in the middle. So all of the sensors are working through the I2C multiplexer in here.
Awesome. So you said the forward one's going a little crazier. I think I see 178 and 218 for I guess that's left and right, or right and left. So you know, that puts you around like half a foot to 2/3 of a foot, you know, a handful of inches away. So those time of flight sensors, are they seeing, like, for example, to the right, or at least in the video it's to the right, are those time of flight sensors seeing those wires and saying that's like the nearest object?
It depends, because on the actual sensor there's a receiver and then there's an emitter. There are two like gold boxes on the black sensor if you were to look up the sensor name. So I guess if a wire was to hit it, then yes. I haven't tested with something like hair. I do want to test that though, because that would be important if it's going on your head.
Yeah, I don't assume that would be a problem. I was just wondering because that seemed like a pretty short distance, and I was just looking at your desk wondering what it was that those sensors were seeing.
Oh, I have something like right off camera here that's
Okay.
probably reading. Actually, I have a power supply there. So what I'm doing right now is I am setting up the TensorFlow. And actually, before I do that, I was originally going to be using something called a Coral dev board. And Coral is created by Google, who also created TensorFlow. And they're in my opinion, the leading company, or TensorFlow is the leading software in artificial intelligence. And they have a mini PCIe accelerator. And remember, I said that there's a PCIe port on the I/O board. And they also have the dev board, which looks like a Raspberry Pi, just with a big heatsink. It ended up, it would be too expensive, and the heatsink is too large for my application. But if you want really powerful AI, I would get a Coral. And also, teachable machine. I originally mistook this when I was creating this between image classification and object detection. Image classification, it's so easy. You can go online, you can import your images, train it, and you get a model instantly online. It's crazy. But object detection, it detects individual objects in the frame. And that could be as many objects as there are in the frame. And in order to do that, you have to use a special software, and you have to painstakingly go through each image and capture. You have to draw a box around the thing that you want. That's the next thing that I'm actually going to work on. So here I'm using a sample model, which has, I think, 80 objects. One of them includes a person, which I'll be demonstrating because I am a person. And when you run this program, it's running inside of a virtual machine. It is using the distance sensor, which is this printed output right here. So if I take the camera, which is below the screen, and I point it at my face, it prints out person with a confidence score of how confident it is that what it's seeing is a person, and the distance sensor, which I kid you not, I implemented an hour ago because I forgot to do it, and apparently it is refusing to work on me. But
It's
trust me,
probably a loose wire or something. It always is.
Yeah. But okay, there we go. It does work. What it's trying to do is, if the distance sensor is below a certain value, it prints out the output, which that part of the code is working. I guess the distance isn't. So here, I guess I can run that again. And it's fun to try and hold up objects and see what it can recognize. Like I could maybe get it to recognize. I don't want to get my head in the frame here. I could maybe get it to recognize the phone. Maybe, maybe not. Okay. And you can hold up different objects and see what it thinks it is. Oh, there we go. The distance sensor is working now. Oh, no, never mind.
Mhm.
Oh, wait. I'm using the left distance sensor. That's why it's not going. Instead of the, yeah. I'm using the left
Okay.
distance sensor instead of the forward one. But yeah, that is using TensorFlow Lite, which is a smaller version of TensorFlow. It runs at about 5 frames a second, which is pretty good considering there are 80 objects. So it can detect, again, multiple objects in the frame, and it will be used to detect things like doors, stairs, people, cars, if you're going outside. Those are all things that a blind person would want to know so they don't get injured. And that's why I'm creating a custom data set to train those different objects.
That's awesome. Yeah, I mean, I remember when like you said before, you were asking me on Discord about some of the, absolute tracking or absolute distance tracking using just the accelerometer gyroscope. And, I don't think I heard too much past that, but all this other stuff you implemented is awesome. We do have a
Thank you.
question.
Thank you.
Ankur is still in the chat. He says, what are you using for the voice recognition?
The voice recognition, I believe I'm using Google Cloud. So you do have to have Wi-Fi in order to use the assistant. But I found that was the most accurate. You could speak really fast or really slowly. It would work. And it was really quick too.
Did you research any offline voice interpreters?
I did. Actually, it was Mozilla Deep. I think it was Deep Speech. And I got it the package installed successfully, which is a task when you're dealing with Linux. And I tried to do the audio recording. It did not recognize my voice. I tried speaking slow, fast, enunciate my words. Nothing worked. It wasn't great, in all honesty, but the text to speech is offline.
Nice. All right. Well, I definitely want to see how this project progresses. This is farther than I thought it was going to be. This is awesome.
Zekrom, I actually had that idea very recently. I'm planning on creating or quote unquote like hacking a USB port into the actual glasses to allow the user to upgrade with, I don't know if you've heard of it, it's called the hologram SIM, and it's a SIM made for developers. And probably integrating that with the GPS would allow for like Google Maps navigation if they were outside. I do have a GPS, not here, but that does work. So thank you for bringing that up, Zekrom.
Nice. Well, unfortunately, I don't think we have enough time to go over everything that I'd like to go over. We do have to get to the game jam, but I'm extremely excited to see where this project goes. I will go ahead and say, I have a '90s party this weekend, and I was looking up some crazy *90s style clothing that I could wear there, and I found this crazy hat that has pockets in it. So if you're looking for a hat to use to start prototyping this onto somebody's head, let me know, and I think I can find a very Technicolor hat for you to experiment with.
That actually might be useful because I really don't want to design a glasses frame in Fusion.
No, I mean, if you asked me, maybe I'd help with that, but I think I'd rather see you wearing that hat. It's pretty great. All right, so thanks again, James, for showing us this project. It was very, 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 very awesome to see. I've heard it talked about for a while. This is my first time seeing it. Very excited to see what you do in the future.
Thank you.
So, no problem. Thank you. So, coming up next, we have the Game Jam. We'll be back in just a minute to evaluate the projects and announce the winners. Stay tuned.